Hello everybody. In this video we're going to cover the derivation for the surface area of a cone. Okay, so again, if you're able to follow the lesson, you should be able to complete this success criteria question at the end of the video. So try that at the end. So let's get started. So to find the surface area of a cone, first we consider just a circle with radius s. And again, the radius is the distance from the center of the circle to the edge of the circle. Okay. Let's call this circle figure 1 in case we need to reference it again. Okay. So find the area of this circle is the first part that we need to complete. So the area of this circle of figure 1 is going to be pi radius squared. But the radius here is given as s. It's going to be pi s squared. Okay, and the second part, it asks you to find the circumference of the circle. So again, remember that the formula for circumference is 2 times pi times the radius. But the radius of this circle is s, so it's 2 times pi times s. Okay, so the first two parts were very straightforward. Now let's consider this. Consider a figure, a Pac-Man-like figure, that is the original circle, but this part, but a portion of it cut out. So let me write that in red. The red portion is cut out. Okay. And then we'll call this Pac-Man figure, figure 2, in order to reference it. So again, it's the same circle, except this part is cut out, so the radius would be still s. So this new figure has a smaller or larger area than the circle. Well, if you take a look, there's a portion cut out from the original circle, so the area must be smaller. Now this is the most important part. If we take the figure 2, the Pac-Man figure, and we connect the two sides labeled s, so here's s and here's other s, and when we take these two sides and join them together, we get a cone. So here is a small video that shows that. So here is a Pac-Man-like figure, and then when you connect the two edges, it turns into a cone. Pac-Man-like figure, connect two edges, turns into a cone. Okay. So when it's turned into a cone, we realize we get a new radius, the radius of the bottom face of the cone. So the radius of the bottom face of the cone is given by this letter r, variable r. So find the circumference of figure 2 is the next question. So finding the circumference of figure 2, which I'll label in orange, is pretty difficult to find if we just look at figure 2. However, it becomes very simple if you consider figure 3. The orange part, the circumference of the bottom face of figure 3, must be equivalent to the orange part, the circumference of figure 2. Okay, so let's take a look at the video again just to verify that. So here again is the Pac-Man-like figure, and we see that the Pac-Man-like figure has the circumference here, which is cut out from the original. And if we join the two edges of this figure, we get a cone. And once we get that cone, we realize that the circumference of the cone is the same length as the circumference of figure 2, the Pac-Man figure. So you join, and then you see that the circumference of the bottom face of the cone is the same length as the Pac-Man circumference. So to find the circumference of figure 2, the Pac-Man figure, that is just going to be equal to, circumference of figure 2 is the circumference of the bottom face of the cone in figure 3. Circumference of figure 3, which is equal to pi times the radius, 2 times pi times the radius, r. There we have it. Now, this is also one of the most difficult parts, finding the area of figure 2 shape. So let me show that in yellow. So we need to find the area of this portion of the Pac-Man figure, figure 2. And the way we're going to do that is through finding the fraction of the circumference that's left over after the cut of the original circle and multiplying that by the area of the original circle. To make that more clear, we're going to go through an extra example. So we're going to find the area of the following, this figure. This figure is 3/4 of the original. Okay? And the area is going to be 3/4 times the area of the original circle, which is pi times the radius squared, which is 3/4 pi. Okay, so I'm doing this way just to show that our answer is going to be correct by doing it another way. The other way we're going to do it is by taking the fraction of the circumference that's left over. Okay. The fraction of the circumference that's left over is going to be exactly 3/4 times 2 times pi times r, which is 1. And then we're going to divide that by the whole circumference, which is 2 pi 1. This would be the circumference if it was just a circle with no cut out portion. That's 1. So this becomes the fraction of the circumference of the cutout. Or the left out, the leftover. So this is a fraction of this circumference. So the area of this cutout figure, the cut leftover, the area of the leftover figure is going to be the fraction, which is 3/4 times 2 pi r, which is 1, over 2 pi r, which is 1, times the area of the original circle. And the area of the original circle is pi r squared. So area of this figure is going to be equal to 3/4. The 2 pi divided by 2 pi was 1, so we don't have to write that anymore, times the area of the original circle, which is pi r squared, pi 1 squared, which is equal to 3/4 pi. So as you can see, the answer is exactly the same. This is not a full proof, but it does show that it works for one case, which we're going to use as a proof because we haven't covered proofs yet. But this shows that if we get the fraction of the circumference and multiply it by, so we got the fraction of the circumference. So we take the fraction of the circumference and multiply by the area of original, of the uncut, then we get area of the cut, leftover cut, leftover after cut. Okay, so that's exactly what we're going to do to find the area of this figure 2, this shape right here. Okay, so we're going to find fraction first, fraction of the leftover after the cut. So fraction first. So the fraction of the leftover after the cut is going to be the circumference of this part. Circumference of, let me use blue. Circumference of this, the circumference of figure 2, divided by the circumference of figure 1, the full circle, with a radius of s. Figure 1. Okay, so again, the circumference of figure 2, we figured that out here, 2 pi r. So the fraction is going to be 2 pi r, all divided by the whole circumference. So again, we had the whole circumference at the very beginning here, whole circumference right over here. 2 pi s. Okay. And then the area of figure 2, so the area of this in red, box in red, is going to be equal to the fraction times the area of the whole circle. Area of the whole circle which was figure 1. So the fraction is 2 pi r divided by 2 pi s times the area of the whole circle. And the area of the whole circle we have up here in our previous page, pi s squared. Pi s squared. Now we can simplify this a bit because 2 pi divided by 2 pi is 1. We get r divided by s times pi times s times s. If you divide s and then multiply s back, that's just doing nothing. So we got r times pi times s. So then this simplifies to r pi s. Or we usually like to write the pi first or second. So we got pi rs. So the area of the top part of the cone is going to be pi times r times s. Because after we join the two edges of figure 2, we only get the top portion of the cone, this top portion, not the bottom face of the cone. The bottom face of the cone is going to be easy to calculate. The bottom face of the cone is just pi times the radius squared. And the radius is r. Looking at figure 3, you see that we gave it the letter r. So now we find the total area. Area total is going to be pi times r times s plus the bottom face, pi r squared. Again, this was the cone, figure 2. That's the top part of the cone. So the formula for the area of a cone is going to be equivalent to this total area here. Pi rs plus pi r squared. So let me just clarify what this is, what r is, and what s is again of the cone. So the r is the radius of the bottom face of the circle, r, and then s is the slant height. It's the distance from the top of the cone to the edge of the cone, edge of the circle of the cone, and this is s. Okay, this is this, and r is the radius here, and this r radius is the same as this. So let me explain why this was a slant height again. So if we look up here, remember we took the Pac-Man-like figure and we joined the edges, which made this cone. But when you join the edges, you realize this red line right here are the joined edges, and it is the slant height of the cone. So let's take a look at the video. So the edges here were s, length s, and when you join it together, it becomes the slant height. The height from the top of the cone to the edge of the circle. It's on a slant. That's why it's a slant height. Okay. So again, we derive the formula for the area of a cone, pi times r times s plus pi r squared. This is the area, the surface area, just to clarify. Okay, so that's the end of the video. I know some portions of this video can be quite confusing, so please email me if you have any questions. Try the success criteria question by yourself and see if you can get that. And that's it for this video. See you next time.